Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to AWS Key Management Service, or KMS, a powerful tool that helps you create and manage cryptographic keys in the cloud. We'll cover what KMS is, why it's important, how it fits into AWS security best practices, and walk through some common use cases. Let's get started. AWS Key Management Service, or KMS, is one of the foundational building blocks for securing data in the cloud. So what exactly is AWS KMS? Simply put, it's a fully managed service that allows you to create, control, and manage the cryptographic keys used to encrypt and protect your data. In today's digital world, where data security and privacy are top priorities, having a centralized and reliable way to handle encryption keys is critical. And that's exactly what KMS offers. At the heart of KMS is key lifecycle management, from key creation, rotation, and usage, all the way to secure deletion. This centralized control ensures consistent security practices across your environment without having to build and maintain your own cryptographic infrastructure. One of the biggest strengths of KMS is how well it integrates. It works seamlessly with over 100 AWS services, from S3 and EBS to RDS and Lambda, enabling you to encrypt data at rest or in transit with just a few configuration steps. This tight integration means you can apply encryption broadly without needing deep expertise in cryptography. When it comes to compliance and security, AWS KMS is built to meet some of the most rigorous standards in the industry, including FIPS 140-2, PCI DSS, and HIPAA. Whether you're working in finance, healthcare, or government sectors, KMS helps you maintain trust and meet regulatory requirements. To support visibility and accountability, KMS works hand in hand with AWS CloudTrail, capturing detailed logs of every key usage and management action. This audit capability is essential for compliance reporting, security analysis, and incident response. KMS also follows a pay-as-you-go pricing model, so you only pay for what you use, based on the number of keys you manage and the API requests you make. There's no need for large upfront investments in hardware or software. For global workloads, KMS supports multi-region key replication, making it easier to build secure cross-regional applications with minimal latency and high availability. And finally, KMS is secure by design. It uses dedicated hardware security modules, or HSMs, to protect your keys, shielding them from both physical and virtual attacks. This means your keys never leave the secure boundary of the service. At the core of AWS KMS are keys, the primary resources used to encrypt and decrypt your data. These keys can either be AWS managed or customer managed. AWS managed keys are automatically created and maintained by AWS on your behalf, making them ideal for quick starts and simplified security. Customer-managed keys, on the other hand, give you full control over key policies, rotation schedules, and usage permissions, perfect for more advanced use cases or compliance-sensitive environments. Each key in KMS has what's called key material. This is the actual cryptographic secret. You have options here. The key material can be generated by KMS, imported from an external system, or generated within an AWS Cloud HSM cluster for those requiring dedicated hardware security. Access to each key is governed by a key policy, a powerful JSON document that acts as the main access control layer. It defines who can use the key, manage it, and even who can update the policy itself. Key policies are a foundational concept for securing your keys properly. But sometimes, you might want to delegate temporary or scoped access without altering the key policy. That's where grants come in. Grants allow you to assign specific permissions to users, services, or applications, ideal for short-term or use case-specific access. Behind the scenes, KMS uses a key hierarchy that supports envelope encryption. In this model, customer master keys, CMKs, encrypt data encryption keys, DEKs, which in turn encrypt your actual data. This layered approach enhances both performance and security. To make managing keys easier, you can assign aliases, friendly names like finance key or prod key. Aliases can point to different keys over time, which is especially useful during key rotation or when swapping out keys without rewriting application code. Finally, every key in KMS has a state, such as enabled, disabled, pending deletion, or deleted. These key states determine whether the key is usable, and help control the key lifecycle securely and predictably. First, it's important to know that KMS is a regional service. This means that your keys are created and stored in specific AWS regions, and generally they're used to encrypt and decrypt data only within that same region. This design supports both data residency requirements and localized security control, especially useful for organizations with global compliance needs. KMS operates with two distinct layers, the control plane and the data plane. The control plane handles administrative actions, like creating keys, setting policies, or enabling key rotation. The data plane is responsible for actual cryptographic operations, like encrypting or decrypting data. These two planes are independently scalable, allowing AWS to optimize performance and reliability based on usage patterns. At the heart of KMS security are AWS Managed Hardware Security Modules, or HSMs. These are specialized physical devices used to generate, store, and protect your cryptographic keys. The key material is never exposed in plain text outside these HSMs, providing a strong layer of protection against both physical and virtual attacks. For high availability and resilience, KMS uses a distributed multi-AZ architecture. Key management systems are redundantly deployed across multiple availability zones within a region. This ensures that key operations remain available even in the event of infrastructure failures. To improve performance and reduce overhead, KMS supports key caching. When you use envelope encryption, data encryption keys, or DECs, can be cached locally, so your applications don't have to call KMS for every encryption or decryption operation. This can significantly lower latency and reduce your KMS API usage. Speaking of API usage, KMS enforces throttling and quotas. These are default limits on the number of requests you can make per second, designed to prevent misuse or abuse. However, these limits can be increased through AWS support if your workload requires higher throughput, a common scenario in large-scale applications. For even greater control, KMS integrates with AWS Cloud HSM through a feature called Custom Key Stores. This allows you to generate and store keys in dedicated HSM clusters that you fully manage, giving you deeper control over key lifecycle and compliance posture while still using the familiar KMS interface. When securing your data in Amazon S3 using AWS Key Management Service, you have several options for managing your encryption keys, each with varying levels of control and complexity. Let's explore three key approaches. First, we have the AWS KMS only model. This is the most straightforward option. Here, AWS KMS handles everything for you using its built-in, highly secure hardware security modules, or HSMs. When S3 needs to encrypt or decrypt data, it asks KMS for a data key. That data key is protected using a customer master key that lives entirely inside AWS's infrastructure. There's no extra setup required, making this a great default choice for most use cases. Simple, secure, and fully managed by AWS. Next, let's look at AWS KMS with a custom key store. This is where you bring in AWS Cloud HSM. While KMS still manages permissions and API access, the actual keys are stored in a dedicated HSM cluster that you own and operate. When S3 requests a data key, KMS retrieves the key from your Cloud HSM setup. This model offers greater control and isolation, ideal if you need to meet stricter compliance requirements or want more visibility into key storage. Finally, there's AWS KMS with a third-party solution. This option is for organizations that already have a key management system in place, either on-premises or from a third-party provider. In this model, the encryption key is generated and stored externally, then imported into KMS. S3 can still use that key for encryption, but the root of trust remains with your external HSM. This approach is perfect for meeting regulatory mandates or continuing to use an existing key infrastructure while still benefiting from AWS KMS features. Each of these models offers a balance between ease of use, control, and compliance, and the right one depends on your organization's needs. Managing encryption keys isn't a one-time task, it's an ongoing lifecycle. In this section, we'll walk through the key management lifecycle in AWS KMS, step by step, to help you understand how keys are created, used, maintained, and eventually retired in a secure and controlled way. It all begins with key creation. When you create a key in KMS, you have several options to configure. You can choose whether the key material should be generated by AWS, imported from an external source, or backed by a cloud HSM cluster. Next comes key enablement. A key must be in the enabled state to be usable for encryption or decryption. This state is important. It allows you to control whether a key is actively usable in your environment. You can also disable and re-enable a key at any time as part of your operational workflows. Over time, best practices recommend updating key material, and that's where key rotation comes in. AWS KMS supports automatic rotation for customer-managed keys every year, helping reduce the risk of long-term key exposure. To maintain visibility into your key usage, key monitoring is essential. Every action involving a KMS key, whether it's a use, an update, or even an access denial, is logged via AWS CloudTrail. These logs are critical for audits, security reviews, and operational insight. Sometimes you might need to temporarily disable a key without deleting it. For example, during a maintenance window or when investigating suspicious activity. Disabling a key immediately prevents its use, but it can be re-enabled later if needed. If a key is no longer needed, you can schedule it for deletion. AWS enforces a mandatory waiting period between 7 and 30 days. This delay helps prevent accidental or rushed deletions and gives teams time to react if a key is scheduled in error. To further protect against mistakes, you can set deletion prevention safeguards, such as using IAM policies or external processes to limit who can schedule deletions or require multiple approvals. If a key is mistakenly scheduled for deletion, AWS gives you the chance to cancel the deletion during the waiting period, allowing you to recover the key and resume using it without data loss. By understanding and applying the full key management lifecycle, from creation and rotation to monitoring and recovery, you can confidently operate a secure and compliant encryption strategy using AWS KMS. Choosing the right key type is essential for building secure, efficient, and scalable encryption workflows. We'll start with the most commonly used, symmetric keys. These keys use the AES 256 GCM algorithm, a widely trusted standard for encryption and decryption. Symmetric keys are used when the same key both encrypts and decrypts the data. This is the default key type in KMS and supports encryption at rest across services like S3, EBS, RDS, and Lambda. If you're just getting started, chances are you'll be using symmetric keys most of the time. Next, we have asymmetric RSA key pairs. These are made up of a public key and a private key. Ideal when you need to separate the party that encrypts data from the one that decrypts it. For example, if a client app encrypts data using a public key, only your server with the private key can decrypt it. Asymmetric RSA keys are great for secure communications or scenarios where key sharing needs to be controlled. Closely related are asymmetric ECC keys, which use elliptic curve cryptography. These are more efficient than RSA keys. They provide strong security with smaller key sizes. ECC keys are especially useful for digital signatures, where you want to verify data integrity and authenticity with minimal performance impact, perfect for APIs or IoT applications. Another option is HMAC keys, which are used to create hash-based message authentication codes. These keys are ideal for verifying that data hasn't been tampered with during transmission. You'll often find HMAC used in signing web requests, verifying tokens, or implementing secure messaging between services. For workloads spanning multiple geographies, multi-region keys are available. These allow you to replicate the exact same key across AWS regions. Multi-region keys are critical for cross-region disaster recovery, global data replication, and reducing latency for geographically distributed applications, all while maintaining encryption consistency. Cryptographic operations are the building blocks that allow you to protect your data and ensure secure handling of sensitive information. At the core of KMS are the encrypt and decrypt operations. These are straightforward and typically use symmetric keys. You send your plaintext data to KMS, it encrypts it and returns a secure ciphertext. To decrypt, you simply send the ciphertext back, and KMS returns the original plaintext, all handled securely and efficiently by AWS. A very common pattern with KMS is envelope encryption, which is where the generate data key operation comes into play. This generates a unique data encryption key, DEK, that your application can use to encrypt data locally. KMS also returns an encrypted version of that same DEK, which you can safely store alongside the data and decrypt later when needed. This approach improves performance because it reduces the need to send every encryption request to KMS. Sometimes, you don't need the plain text version of the data key. For example, when you're just rewrapping or transferring encrypted data. That's where generate data key without plain text is useful. It returns only the encrypted form of the data key, helping you maintain tight control over key material exposure. For scenarios involving digital signatures, KMS supports sign and verify operations with asymmetric keys. You can use a private key to digitally sign a message and then allow others to use the public key to verify that the message hasn't been tampered with. This is especially useful for secure APIs, data integrity checks, and identity validation. The re-encrypt operation allows you to transition encrypted data from one key to another, decrypting and re-encrypting it in a single secure step without ever exposing the plain text to your application. This is ideal for key rotation or transitioning to a new key policy. To add an additional layer of protection, KMS supports encryption context. This is optional metadata you can include with your encryption request, like a tag or label. When you try to decrypt, KMS checks that the same encryption context is provided. If it doesn't match, the operation fails. This helps prevent misuse or accidental decryption in the wrong context. One of the most powerful and widely used features in AWS KMS is the envelope encryption pattern. It's a design pattern that balances strong security with high performance, especially when you're working with large volumes of data. So what is envelope encryption? At a high level, it involves two layers of encryption. You use a data key to encrypt your actual data. This might be files, database records, or any kind of sensitive information. But instead of managing the data key yourself, you use KMS to generate and protect it. The KMS key, often called the Customer Master Key or CMK, doesn't encrypt the data directly. Instead, it encrypts the data key. That's the envelope. Your data is protected by a key, and that key is itself protected by another key. This model offers a number of benefits. First, it dramatically reduces the number of API calls to KMS, since you can reuse the same data key within a secure boundary, like during the processing of a batch or session. This improves both performance and cost efficiency, especially important at scale or in low latency environments. Let's break down the implementation process. You start by calling KMS to generate data key. KMS returns two versions, a plain text data key and an encrypted data key, the latter protected by your KMS key. You then use the plain text key locally to encrypt your data. Finally, you store the encrypted data key alongside the encrypted data, such as in an S3 metadata field or a database column. When it's time to decrypt, your application retrieves the encrypted data and the encrypted data key. It sends the encrypted key back to KMS, which decrypts it and returns the plain text version. That key is then used to decrypt your data. Importantly, the KMS key never sees your actual data. It only handles the key that protects it. You can also implement caching strategies to reuse data keys securely. For example, within a processing thread or session, you might reuse a single data key to encrypt multiple objects, as long as you're careful about maintaining isolation between contexts. This helps reduce load on KMS and boosts throughput. There's even support for data key pairs, an asymmetric variant used when you need public and private key pairs for encryption or signing. This is useful in public key cryptography scenarios, where only one party should decrypt or sign. When it comes to securing your keys in AWS KMS, access control is handled primarily through key policies and IAM policies, and both play a crucial role. Let's start with resource-based policies. Every KMS key has exactly one key policy, which is a JSON document that directly controls who can use or manage the key. It includes standard policy elements like principal, who's making the request, action, what they can do, resource, the key itself, and condition, any specific requirements like source IP or encryption context. Now here's something that trips up a lot of users. For most operations to succeed, both the key policy and IAM policy must allow access. This is a logical and. If either denies access, the operation is blocked. That means even if your IAM role has full permissions, it won't work unless the key policy also allows it. When a key is created, AWS applies a default key policy that gives the root user full control and allows IAM policies to grant additional permissions. This setup is recommended because it lets you manage access through roles and groups without having to edit the key policy every time. Access decisions in KMS aren't based on just one thing. They consider the key policy, any relevant IAM permissions, grants, which are scoped, time-limited permissions, and even VPC endpoint policies when you're using private networking. This layered approach gives you flexibility, but it also means permissions must be well coordinated. For cross-account access, key policies must explicitly list the external account's principals. Just sharing an IAM role or ARN isn't enough. The key policy must permit the use. KMS also integrates with service-linked roles, special IAM roles that AWS services use on your behalf. For example, services like RDS or Lambda may need to encrypt data using your keys. The key policy must allow these roles explicitly. Lastly, KMS supports condition keys to give you fine-tuned control. You can limit access by request source, VPC, region, or require an encryption context match. These help enforce least privilege and compliance in sensitive environments. One of the most powerful aspects of AWS Key Management Service is how deeply integrated it is across the AWS ecosystem. KMS doesn't just protect keys, it plays a central role in securing your data across dozens of AWS services. Let's start with Amazon S3, one of the most common use cases. With server-side encryption using KMS keys, also known as SSE KMS, you can encrypt every object stored in a bucket automatically. You get full control over the keys, detailed audit logs through CloudTrail, and the ability to enforce encryption through bucket policies. For Amazon EBS, KMS enables transparent encryption of your block storage volumes. Whether you're running EC2 instances or using snapshots, encryption is seamless and adds no code overhead. While there is a small performance impact in some cases, it's generally optimized for most workloads. Amazon RDS and DynamoDB also support encryption at rest using KMS. In both services, your data is protected with KMS managed keys, and you can bring your own customer managed key if needed. Encryption happens at the storage layer and is completely transparent to your application. In AWS Secrets Manager, KMS is used behind the scenes to encrypt your secrets. Things like API keys, database passwords, and tokens. Every time you store or retrieve a secret, KMS ensures it's encrypted and decrypted securely. Lambda functions also benefit from KMS integration. If your function needs to use environment variables to store sensitive values, KMS can encrypt those variables so they're protected even at rest. For containerized applications running in ECS or EKS, KMS plays a key role in delivering secrets securely. It helps ensure that credentials, tokens, or config values are only accessible to the right workloads at the right time. Even your CloudWatch logs can be encrypted with KMS, which is often a compliance requirement in regulated industries. When using AWS Key Management Service, security is more than just encryption. It's about making sure that your keys are used safely, intentionally, and with control. Let's explore some of the most important security best practices for working with KMS. First, implement a solid key rotation strategy. KMS supports automatic rotation for customer-managed symmetric keys, which helps improve security by periodically changing the key material. Balance the benefits of rotation with your operational requirements, especially when managing manual or asymmetric keys. Always use an encryption context. This is optional but strongly recommended. It acts like a fingerprint for your data, helping ensure that a decryption request matches the original encryption request. Enforcing context prevents misuse, even if someone has access to the encrypted data and the key. Use IAM policy conditions to enforce even more precise access controls. For example, restrict key usage based on time of day, IP address, or whether the request comes through a specific service or VPC. Speaking of network controls, use VPC endpoint restrictions to ensure that traffic to KMS never leaves your private network. This adds an extra layer of isolation and limits exposure to the public internet. It's also a good idea to back up your key policies offline. If a policy is accidentally changed and access is lost, having a saved version ensures you can recover the correct permissions with AWS support. If you're using multi-region keys, remember that each replica has its own access policies and controls. Ensure consistent configurations and be aware of regional security compliance requirements. Finally, Apply the principle of least privilege. Only grant users and services the specific permissions they need to perform their tasks, and nothing more. Avoid broad access, and instead use tightly scoped IAM roles and policies. This reduces the attack surface and limits accidental misuse. Now let's take a closer look at how AWS KMS pricing works. Understanding the cost model is essential to managing encryption at scale and avoiding surprises on your bill. First, let's talk about customer-managed keys. These are the KMS keys that you create and control. Each customer-managed key costs $1 per month, regardless of how often you use it. That means even if a key is never called by an application, the charge still applies as long as it exists. Next are the API request charges. For symmetric keys, which are used in most common encryption operations like encrypt, decrypt, or generate data key, the cost is 3 cents per 10,000 requests. For asymmetric keys, such as those used for signing or RSA encryption, the pricing is higher, reflecting the increased complexity of those operations. AWS offers a free tier to help you get started. It includes 20,000 KMS requests per month at no cost, limited to certain operations like encrypt and decrypt with symmetric keys. This is great for testing or low-volume use cases. It's also worth noting that regional pricing may vary slightly. Be sure to check the current AWS KMS pricing page for the specific region where your keys reside. What about AWS managed keys? These are the default keys AWS creates and manages on your behalf. For example, when you enable encryption in S3 without specifying your own key. With AWS managed keys, there's no monthly key charge. You only pay per request fees when the key is actually used. If you choose to use a custom key store, which integrates KMS with your cloud HSM cluster, additional charges apply for the underlying HSM infrastructure, on top of standard KMS fees. Multi-region keys are another special case. When you replicate a key to another region, each replica is billed separately at the same $1 per month rate. And finally, with external key stores, where key material lives outside AWS but is controlled by you, there are additional costs for proxy operations and communication with your external systems. As your use of AWS Key Management Service grows, it's important to think not just about security, but also about cost efficiency. Let's look at a few practical strategies to help optimize your KMS usage and control spending without compromising data protection. One of the simplest ways to save is through key consolidation. Instead of creating a new KMS key for every application or resource, look for opportunities to reuse existing keys where appropriate. Reducing the total number of customer-managed keys can significantly lower your monthly fixed costs. Next, consider using data key caching. This allows your applications to cache data keys locally for a short time, reducing the number of generate data key or decrypt requests to KMS, and in turn, cutting down request-based charges. AWS services like the AWS Encryption SDK make this easy to implement securely. For applications handling large volumes of data, be strategic with your encryption. Use targeted encryption to protect only sensitive fields, like personally identifiable information, rather than encrypting entire data sets. This reduces both storage overhead and KMS usage. Cross-account key sharing is another great way to optimize. Instead of provisioning separate keys in every account, you can create centralized KMS keys in a shared security or audit account and grant access to other accounts. Fewer keys mean lower monthly fees and easier policy management. Always keep an eye on API usage patterns. Use CloudTrail or AWS Cost Explorer to identify unexpected request volumes or unused keys that can be disabled or deleted. You can also batch encryption operations where possible. Instead of calling KMS for every single item, consider grouping data for more efficient processing. In many cases, service-native encryption using AWS managed keys is perfectly sufficient. These keys don't carry a monthly key charge, so use them where full control or key rotation isn't required. Finally, apply cost allocation tags to your keys. Tagging lets you break down KMS charges by team, department, or project, giving you better visibility and control over where your encryption budget is going. Monitoring and logging are essential parts of any secure and well-managed encryption strategy, and AWS KMS provides powerful tools to help you stay in control of your key usage. Let's start with AWS CloudTrail. KMS integrates seamlessly with CloudTrail to automatically log every API call made to the service. Whether it's a request to encrypt data, create a new key, or change a key policy, these events are recorded in detail. This gives you a complete, tamper-resistant record of who did what and when, crucial for accountability and forensic investigations. You also get CloudWatch metrics for your KMS keys. These include operation counts, such as how many times a key was used to encrypt or decrypt data. This visibility helps you understand usage trends and determine whether some keys are overused or not used at all. To take monitoring a step further, you can configure CloudWatch alarms. These can alert you to things like sudden spikes in API calls, potential quota exhaustion, or unusual access from unfamiliar IAM users or services. These alarms act as an early warning system for suspicious or unexpected activity. When reviewing logs, look for patterns. Are certain keys being accessed more often than expected? Are API calls being made outside of normal business hours? These signs can help you spot potential security risks before they become bigger problems. From a compliance standpoint, KMS logs are invaluable. You can use them to produce evidence for auditors, showing exactly how keys were used and that access controls are working as expected. If you operate in a multi-account environment, consider centralized monitoring. By aggregating CloudTrail logs and metrics from different accounts, you get a full picture of key usage across your entire organization. Another best practice is encryption context validation. This ensures that requests to decrypt data include the correct context, adding a layer of protection against misuse. Finally, by continuously reviewing logs and metrics, you can quickly detect and respond to unauthorized access attempts, helping you keep your encrypted data safe. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.